3 lectures for this group. So I think we have to put some extra lectures. I will be finishing differential equations functions. So
we have to give them the mid exam also. No?
Yes, we will give them next week on Thursday. I will tell them.
Okay, sir.
Okay. Yes. How many are there today? I cannot.
16, sir. That means 14 students.
Yes. It's 8 o'clock now.
Yeah, I put them a message also, sir. They will join.
Now the power cuts are not there in the morning, no? Anywhere in the island?
Yes, sir.
Yes, so. My 25. Students, first years have gone there yesterday, no?
Yes, sir. But I didn't hear from them yet. We'll ask from Yamani because I asked them to visit the department if possible.
Some students were sad because people who did not get Mahapala could not participate yesterday. No?
Yes.
So they were sending messages saying with the bursary, some students also can come to the campus for a similar function. 8:03, start at 8:05. I'm not sure whether they have another lecture at 9.
Okay, sir. I think some of them has a lecture on 9.
Yes. So we have to stop at 9 also. Students, can you hear me?
Yes.
Can see the screen also. 37, 35 students still. I'll start now, okay? And
Recording in progress.
Good morning, students. Let us start by reviewing what we did last time. We started second order linear differential equations with constant coefficients. So those are of the form d2a d2y over dx squared plus b dy over dx plus cy is equal to 0, where a, b, and c are constants. It's commonly written this way also. Ay double dash plus by dash plus cy is equal to 0. Now we said to solve this equation is to find two linearly independent solutions. One solution should not be a multiple of the other. Second order equation, so let us call this star, this or this, they are the same star. We proved last time that the auxiliary equation for this differentially, lots of words there. Second order, highest derivative is the second order derivative in the equation. Second order, such equations are called even with a, b, and c replaced by functions of x. We call such equations linear second order equations. Now, special case that we consider here is when the coefficients of these derivatives and y are constants. A, b, and c are numbers. Auxiliary equation for such a second order linear differential equation with constant coefficients. Just look at this. That's enough. Auxiliary equation is a second derivative. We put m squared plus bm plus c is equal to 0. Auxiliary equation for this is obtained by replacing double dash by m squared dash by m and delete the y. So after writing the auxiliary equation, it is a quadratic equation in m squared. So it's like ax squared plus bx plus c. Instead of x, we have m. Okay, so we said if this equation, so everything is done using this equation, we said y equals e to the m1. So this equation, suppose it has a solution m equals m1, then we said y equals e to the m1x is a solution. Is a solution. So that was so I proved that also last time. So maybe it was a bit difficult to grasp straight away. But all we are saying is, if we take this and substitute it into this equation, okay, so we get a m1 squared plus b m1 plus c is equal to 0 times, that part times e to the m1x equal to 0. So if m1 is a solution of this equation, then y equals e to the m1x is a solution. Now, considering the auxiliary equation, we will continue the study of finding general solutions of the given equation. General solution. So that depends on the roots of this equation. Let us call this equation double star, auxiliary equation of star. Okay. So case 1. That is what we did last time. I will review that again with an example. Case 1. double star, meaning auxiliary equation, has two distinct real roots. That is the first case. Two distinct. It's a quadratic. No? One of three things can happen. Two distinct real roots, coincident roots, meaning equal roots, or complex roots. So first case, it has two distinct real roots. Let m equals m1 and m equals m2 are the solutions of star, solutions of double star. Suppose these are the this is two distinct real roots case, two distinct real roots. So in that case, from the theory, we know e to the m1x is a solution. If m equals m2 is another solution, then e equals m2x is also another solution. Then the general solution becomes then the general solution. General solution, and the general solution of star, meaning differential equation, is y equals c1 e to the m1x plus c2 e to the m2x. So no, nothing. I mean, it's just solving a quadratic equation. To solve the differential equation, we write the auxiliary equation and check the cases, find the roots. If the roots are distinct, this is the general solution where m1 and m2 are where c1 and c2 are arbitrary solutions. Okay, now even if you were not there last time, still try to follow this. Given a differential equation, write down the auxiliary equation, solve the quadratic equation. That auxiliary equation is a quadratic if it is second order linear differential equation with constant coefficients. Find the solutions. If the solutions are distinct, m1, m2, we did the theory last time, so we can straight away write down the general solution. Two linearly independent solutions we get, e to the m1x and e to the m2x. They are m1, m2 are different, so we can solve it quite quickly when we have such a equation. So I want to do wait. We'll do an example for this case. See whether you understand it well. Okay, give me 1 minute to get this. Solve y double dash minus 5y dash plus 4y is equal to 0. How do you solve this second order linear differential equation with constant coefficients? What is A, B, and C here? A is 1, B is minus 5, C is 4. Okay, how do you solve? So we have to write down the auxiliary equation. Auxiliary equation is, how do you write the auxiliary equation? Instead of y double dash, we write m squared. Y double dash, how to write down the auxiliary equation? Y double dash gets replaced by m squared. Y dash gets replaced by m to the power 2, m to the power 1, y replaced by m to the power 0. meaning just 1. Y replaced by 1. M to the power 0. Y replaced by 1. Okay, this is what you have to do to get the auxiliary equation. Can somebody tell me the auxiliary equation for this? Now, earlier, what was it? If it is a y double dash plus by dash plus cy equal to 0, instead of y double dash, we put m squared. Y dash, we put m. Y, we put 1. Okay, so what is the auxiliary equation? A m squared plus b m plus c. This is this differential equation. For this, we put m squared, m, and for y, 1. So if you do that to this equation, can somebody tell me the auxiliary equation? Instead of y double dash, we put
m squared.
Yes, very good.
5 m
Squared minus 5m, yes,
plus 4.
plus 4 equal to 0. That is all that you have to do to solve this differential equation. You get this. This is a quadratic equation in m. Okay, it's like ax squared plus bx plus c equal to 0. Quadratic equation we can solve easily if it factors. So let us just get the yes, solve. Okay. So now what do we do? So factor this. What are the factors of this? Equal to 0. M squared, m, 4. Here this is 5. No? So the factors should be 4 and 1. 1, 4. This is plus, this is minus. Therefore, both must be minuses. Just factor the quadratic equation. It factors. So from this we have m minus 1 equal to 0 or m minus 4 equal to 0. No need to write this step. You can straight away write the next one. M is equal to 1 or m is equal to 4. Do you all understand this in the morning? First thing. Okay. Now write down the general solution. Therefore, the general solution therefore the general solution of our differential equation y double dash minus 5, just write general solution. This for completeness sake I'm writing it this way. Therefore the general solution of the given equation is y equals, all you have to do is c1 e to the m1x. M1 is 1, M2 is 4. So e to the x, 1x, plus C2 times e to the M2, which is 4.
Excuse me, sir.
Yes, sorry. So if these the roots are M1, this is roots case, no? That is the case that we just reviewed. Y equals C1 e to the M1x. M1 is 1. M2 is 4, where C1 and C2 are, where C1 and C2 are arbitrary, A or B is enough, arbitrary constants. Okay. Now let me do another problem where this auxiliary equation does not factor, but has two distinct real roots. You know, when you have a quadratic equation, if the discriminant, that is b squared minus 4ac, if the discriminant is positive, the equation has two distinct real roots. If the discriminant is 0, it has equal roots, coincident roots. If the discriminant is negative, it has complex roots. So we are in the first case. Now we did the example. See whether you can do the next one. Let us do it together. What is the next example is, sorry, solve y double dash plus y minus 1 equal to 0. Y dash minus y, sorry. Solve this differential equation. What are a, b, and c? A is equal to 1. B is equal to 1. C is equal to minus 1. So how do you solve this? We first write down the auxiliary equation. Auxiliary equation. How do you tell me the auxiliary equation for this one? Auxiliary equation for this differential equation. Yes. Our method. What is it? Y double dash. Yeah. M squared. Yes.
Plus m
Plus m
minus 1
minus
equal
1
to 0.
equal to 0. Y double dash, instead of y double dash, we write m squared. Okay. Instead of y dash, we write m. Instead of y, we write 1. When you do this, okay, everybody can, whether you understand the theory or not, I shouldn't say that you must understand it, but at least the everybody should be able to do the algorithm that we have produced through theory. So theory was done, otherwise you cannot teach it. No, if you just say, take this equation and there is something called auxiliary equation, it is written this way. And then after that, solve this. And if there are distinct roots, the general solution is that is the procedure. Why that procedure works is what we explained last time doing the theory part. So, but for applications purposes, you can follow this. Everybody should be able to do it. Okay, so from this we write auxiliary equation. Then we need to solve this. This doesn't factor. This doesn't factor. If you write, the best way to see it, if you take the discriminant, it's not a perfect square. If it factors, discriminant b squared minus 4ac is a perfect square, factors nicely. But this also, in a sense, has factors. The solutions can be found when it doesn't factor through the quadratic equation. Okay. So if you try to factor, you will fail quickly. M, here factors are 1, 1. You cannot get plus 1 from by putting minuses or pluses in the factored form. They cannot be factored nicely. No nice factors. That doesn't mean that it has no real roots. We can check from the quadratic equation. What is the theory part there? Ax squared plus bx plus c equal to 0. So you have this equation, x is equal to minus b plus or minus square root of b squared minus 4ac divided by what?
2a.
2a. So here we can write, therefore, m is equal to, so minus b. Now this is, instead of x, we have m. So m is equal to, what is b for this one? 1. A is 1, b is 1, c is minus 1. So minus b, minus 1 plus or minus square root of b squared. This squared, 1 squared minus 4 times a is 1, c is minus 1. Minus 1. Divided by 2a. 2 times 1. A is 1. So I use the quadratic equation to write down the solutions. Let us see. Minus 1 plus or minus. What is this number? 1 here. What is inside the square root? 1, 5. Yeah, this is minus 4. No, with this minus, it is plus 4. 1 plus 4. Square root of 5 divided by 2. So again, I have two distinct real roots. Roots are not as nice as the roots of the previous example, 1 and 4. But here, there are again two real numbers, distinct, different. What are they? When you take plus 1, plus sign, you get minus 1 plus square root 5 over 2. The other one, minus 1 minus square root 5 over 2. So those are the two solutions. -1 plus root 5 over 2 is our one solution. The other one is -5 minus square root 5 over 2. So these are the two solutions of the quadratic equation. This is like M1, this is like M2. Therefore, the general solution, we can say G dot S dot general solution of what? General solution of the given differential equation. The general solution of the DE differential equation is, let us write, y equals C1 arbitrary constant, C1 times e to the m1x, e to the, what is it? -1 plus root 5 over 2 x plus C2. What is the other one? C2. It looks, you might say it looks ugly, but it's m1, m2, e to the m1x plus C2, e to the m2x. M2 is mine. If you want, you can factor a minus sign out and write it as -1 plus root 5 over 2. Or just write as it is. If you, that is this times x, where C1 and C2 are arbitrary constants. Do you all understand it? Okay. If it factors in the distinct roots case, its roots can be written down nicely like this, integers. But if it doesn't, still you can use the quadratic equation and use the same procedure. Get the two distinct roots and write this. This function is not a multiple of this one. These two numbers are different. No? So we say we have two linearly independent solutions. One is this, the other linearly independent solution is this. Those are the two linearly independent. Those are two linearly independent solutions of the given differential equation. If you know two solutions are linearly independent, we can write down the general solution by y equals C1 y1 x plus C2 y2x. y1x and y2x are the x are two linearly independent solutions. Do you understand it? Okay. Any questions? Yes, one. Yes, please use the chat box. Let's make it interactive. Sir, could you explain the theory part again, sir? Yes, yeah. If you try to explain the theory part now, okay, it's a fair question, fair request, because I couldn't upload the note before the lecture. Let me yes. I will try to do it very quickly. Yes, I don't want to just say follow the procedure. You will get the answer. That is what we did now. Two examples. Whether you understand the theory or not, you can perform the procedure. Now the theory part done last time was this. Suppose you have this equation. Ask it again. Somebody was going to ask a question. Suppose you have this equation, ay double dash plus by dash plus cy equal to 0. Okay, but how do you say this type of equation classify? How do you classify these type of equations? Second order linear second order. This side is 0, therefore homogeneous. Second, just words. If you understand, if you recognize this is O. Second order, homogeneous linear differential equation. the differential linear DE, no, differential equation with constant coefficients. Constant coefficients. So it's difficult in that sense. Coefficients. So many things said to classify the equation. But when you see examples, we just did two such examples this morning. Second order linear differential equation with constant coefficients. How do you solve it? We said try let. I want to find solutions of this equation. So how do you find solutions of a differential equation? It is a function of x that we substitute for y, which makes this equation satisfied. So we said try. I explained it briefly. If you take the first order linear differential equation, solutions are e to the mx type. So for the second order one also, we try y equals mx. Try y equals mx as a solution to this equation. Try e equals mx. Y equals e to the mx as a solution. If you try this, y dash is going to be m e to the mx. Okay, so what are we doing? We are guessing a solution to this equation. So we need to somehow find two linearly independent solutions of this equation. Second order, two linearly independent. So if it has solutions of this form, if you can find two such solutions, we can write down the general solution. So y dash is e to the mx. What is y double dash? Yes, somebody quickly. Y double dash e to the mx solution derivative is m e to the mx. Okay. This one y double dash m times derivative of this, again m e to the mx.
E to the
M
mx.
squared, yes, m squared e to the mx. So let us call this equation equation 1. Substitute in 1. Sub in 1. Substitute this in 1. If you substitute this in 1, what do you get? Y double dash is m squared e to the mx. So a m squared e to the mx plus second one b m e to the mx. Y dash is this plus c, we took y to be e to the mx. So we are guessing a solution of the second order differential equation satisfying these properties. Now if this is equal to 0, then y equals mx is a solution of that. Look at this equation. We can factor e to the mx out. Then we get am squared plus bm plus c times e to the mx is equal to 0. But we know exponentials are always positive, not 0, not negative. So if this cannot be 0, this part, now we have product of two things. No, this part cannot be 0. That part is non-zero, being an exponential. Exponential graph lies above the x-axis. It doesn't cross the x-axis. Okay, so for this to be satisfied, we must have a m squared plus bm plus c equal to 0. This is called the auxiliary equation of the second order given second order differential equation, homogeneous one. Okay, so what are the possible? This is a quadratic in M. This is a quadratic T, I see. quadratic in M. So there are three cases to consider then. So if this equation is satisfied for an M, then e to the mx is a solution of that. That is the theory part. So if this equation is satisfied, suppose that suppose that SUPPOSC, suppose that M equals M1 is a solution of this, is a solution of this equation. Let us call that equation 2, which we called the auxiliary equation. Solution of, suppose that M equals M1 is a solution of equation 2. Differential equation was labeled 1. Now auxiliary equation is 2. Suppose M equals M1 is a solution of this. Then we said if this one is a solution of that equation, then this equation must be satisfied, which means this equation must be satisfied. If that equation is satisfied, then this is a solution of that equation. So suppose that M equals M1 is a solution of this, then y equals e to the M1x is a solution of 1. Okay. Now this equation, so if you have a solution of this equation, we get a solution of the differential equation. To solve the differential equation, we have to solve this quadratic equation. So now we can, after that, we shall go into finding solutions in different cases that are available or that are there for the quadratic equation. A quadratic equation may have two distinct roots, real, two equal roots, coincident roots, or two complex roots. We just did the distinct roots case. Let me just show you the two problems just quickly. Yes, 38. No? Yes. So take this equation. Okay, auxiliary equation. Write it down. Now you all can do that. After that, we can write down the general solution, because this equation factors auxiliary equation is this. Now it has two distinct solutions. M equals M1, M equals 1, M equals 4. For M equals 1, the corresponding solution is e to the x, e to the mx, M1x. Second solution we get is e to the 4x. So if you have two and they are not multiples of each other, ex and e to the 4x are not, you cannot write e to the 4x as a constant multiple of e to the x. So two linearly independent solutions are there. Therefore, you can write down the general solution. That is also a theory. Okay, if you have two solutions, if y equals y1x and y equals y1x and y equals y2x, functions of x are two linearly independent, solutions of one, then the general solution, meaning any solution, then the general solution general solution of one differential equation is y equals, how do you write the general solution? That is why these are called linear equations, because if you have two solutions, any linear combination, C1 times the first solution plus C2 times the second solution. General solution is this, where C1 and C2 are arbitrary constants. So if you have two linearly independent solutions like e to the x and e to the 4x, e to the x and e to the 4x, then the general solution is C1 e to the x plus C2 e to the 4x. So try to understand what it means to say that we have the general solution. General solution is any solution of that equation. There are no others for this differential equation, for example. Every solution should take the form C1 e to the x plus C2 e to the 4x. Okay, general solution. So we first find two solutions. Check whether they are linearly independent. I will do an example, next example. You will see you can get only one solution, linearly independent solution. But when the auxiliary equation has two distinct roots, we can always get two linearly independent solutions, e to the x, e to the 4x for this example. So general solution is this. Okay, so now we go to the second case. What is the second case? What is the first case? First case we considered was auxiliary equation has, case 1 was double star has two distinct real roots. Double star is the auxiliary equation. Given equation, I labeled it as star. In the theory part, I said this is 1 and this is 2, doesn't matter. Okay. Now we shall again go to case 2. To go to case 2, again, let us write y double dash plus by dash plus cy equal to 0. Auxiliary equation is a m squared plus bm plus c equal to 0. All understand that, no? This replaced by m squared, y dash by m, and y by 1. So we get the auxiliary equation. Now we go to case 2. Case 2. So let us call as in the case 1 that star and this double star. Oh, 1 and 2 is also okay. Case 2, case 1 was this equation. Double star has two distinct real roots. Case 2 is double star has equal roots. Equal roots case. Equal roots. Let us say double star has 4. Coincident roots case. Let us say let m be equal to m1 twice. Equal roots case, let that equal root be m1, meaning quadratic equation be that root, equal roots. So meaning quadratic equation must have its quadratic equation must have equal roots. You don't, so I'll show you. Then if this is a twice quadratic, no, therefore it must have two roots. But here what happens is that the discriminant of this equation is equal to 0. Therefore you get equal roots. Equal roots meaning discriminant 0. Discriminant 0 will give you equal roots. Now I cannot get like in the previous case, M1, M2, there are no two distinct roots for this equation, only one. It appears twice. Therefore, we can only say that then if that is a root, we know then y equals e to the m1x is a solution. Another one, it appears twice. You will again say then e equals m1x. M1 and m2 are equal. M1 and so in another way, M1 is equal to M2 if you follow the previous discussion. So e to the M2x is also e to the M1x. This is so we can only get one solution. This is a solution. It's a solution of star. It's a solution of star. Now we need another. We get only one linearly independent solution of this form. We need another. We need another linearly independent solution of star to write down to solve the equation. We need another linearly independent solution of star to get the general solution, GS, general solution. So general solution. Now you have to believe me here, and I will tell you the procedure to do it. It can be shown that y equals x times e to the m1x is also a solution of star. Solution of star meaning the differential equation. In this case, it can be shown that this is also a solution of star in this case. When double star has, when double star has equal roots. M equals M1 twice. How do you prove that? Again, if you in this case, meaning the quadratic equation has equal roots. If only one root is there twice, then you can get e to the m1x as a solution. Not only that, in such cases, x times e to the m1x is also a solution. So how do you prove this? We have to find y dash. Find y dash. If you want to say this is a solution, find y dash and y double dash, and find y dash and y double dash, and substitute in star, and see that it is satisfied. Try it, find it satisfied. See that it is satisfied. You try, you have to use the product rule. No, this one times derivative of that plus that one times derivative of this. That is to find y dash. Then again, find y double dash, and then substitute. You will see that the equation is satisfied if m equals m1 is a solution, is the equal root of the auxiliary equation. So what is the general solution? Therefore, so I'm skipping that part. So I'm just telling you, and I'm telling you how to verify that. Therefore, the general solution. So now we have we have two linearly independent solutions. Now we have two linearly independent solutions of star. Star is the differential equation. Now we have two linearly independent solutions of star. What are they? In the equal roots case, what are they? What are they? What are those solutions? What are they? Y equals e to the m1x and y equals x e to the m1x. There are, so I proved this one is a solution, the theory part. Second one, when the quadratic equation has equal roots, this will also be a solution. Now these two are, this is not a constant, it's a multiple of this one. This is a multiple of that, but not a constant multiple. Constant multiple is like a number times that. So these two are two linearly independent solutions. Okay, x e to the, this function cannot be obtained by multiplying this by a constant. You have to multiply by x. That is not a constant multiple. Constant multiple is just a multiplication by a number. So what is the general solution? So the GS, general solution. So the general solution is y equals, how do you write the general solution if you have two linearly independent ones? C1 e to the m1x plus C2 x e to the m1x. Where C1 and C2 are arbitrary constants. Now, let me do two problems for this case also. We have about 8 minutes left. So, there's examples for example 1. Example, solve this equation y double dash minus 2y dash plus y is equal to 0. Solve this equation. Write down the auxiliary equation. Auxiliary equation. What is the auxiliary equation? Yes?
M squared minus 2m plus 1.
Plus 1 is equal to 0. Now, this is a perfect square, no? What is it? M squared minus 2m plus 1. If you try to factor, you will get m minus 1 whole thing squared equal to 0. Right? Because see, m squared, twice the product of these two is there, last term squared is there. M minus 1 squared. So this is the same as this equation. From this one, what do we get? M minus 1 equal to 0. So this is m minus 1 times m minus 1. So m minus 1 equal to 0 twice. So we get equal roots case, m is equal to 1 twice. Equal roots case. Equal roots for the auxiliary equation. Equal roots. Therefore, what are the solutions? Therefore, the general solution of this, therefore, the general solution, GS, general solution is of, let us say, call this one, of 1. General solution of 1 is, these are the solutions of the quadratic auxiliary. What are the general solution? What is the general solution of this? Is y equals C1, yes, C1 e to the M1. M1 is 1. X plus, you cannot say C2 e to the x again because it appears twice. Because e to the x, they are the same function. Not linearly independent. They depend on each other. So C1 e to the x plus C2. What is the second solution when it has equal roots?
C2 e to the
X e to the m1x. So x e to the x. That is the general solution where C1 and C2 are arbitrary constants. Next example. Let us try 4y dash plus y double dash. 2y, no, not 2, 4. I need equal roots. No? Plus y is equal to 0. Solve this equation. Second example for that. Write down auxiliary equation. Auxiliary equation is 4m squared. M squared plus 4m. 4y dash m plus what?
1.
1. Instead of y, we put 1 is equal to 0. Double dash m squared dash m and y equals 1 because it's constant. Here, if it is 5y, then it would be 5. So this is the equation. Now, this also has coincident roots. That is the same as 2m plus 1 squared equal to 0. You recognize this. If you want, you try to factor, you get 2m plus 1, 2m plus 1. So 2m plus 1 squared equal to 0. So from this, you get 2m plus 1 is equal to 0 twice, because same factor. Then we have again equal roots. 2m equals minus 1. Therefore, m equals minus 1 divided by 2 twice. So what is the general solution? Therefore, equal roots case again, equal roots. Therefore, the general solution is general solution of 1 is, yes, is y equals C1. Can somebody tell me? Equal roots case. Like in the previous one, we got 1. So what are the two solutions? Is linearly independent ones. E to the x and x e to the x. E to the m1x plus, that is 1. Second one is x e to the m1x. Here, C1, yes. E to the, yes.
E to minus half x.
X plus C2. What is the second linearly independent solution? We said when equal roots occur, it is x times the same, x e to the minus half x, where C1 and C2 are arbitrary constants. Okay, so equal roots case, the theory part, which we did not prove but mentioned, e to the m1x, and the second linearly independent solution is x e to the m1x. Okay, so general solution can be written that way. Now we have 59. So the third case is when this case 3 is when double star, meaning auxiliary equation has complex roots. Time will not permit us to do that. So these three cases I will just mention. Our auxiliary equation is am squared plus bm plus c equal to 0. What is the discriminant of this? Delta. Delta is b squared minus 4ac. So under quadratic equation, we learned this last year. If delta greater than 0, delta could be equal to 0, delta could be negative. So this is the case, in this case, distinct roots, real, distinct roots. In this case, real, equal roots. Third case, complex roots. Complex roots are complex numbers. Complex roots. Here we can say real, equal roots. A, B, and C are real numbers. So here, quadratic equation, how do you get these three cases? We know if you have a quadratic equation, we know the solution. Solutions are given by m is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Here you can think of this as minus b plus or minus square root of delta discriminant over 2a. The three cases are coming from this. If delta is positive, two distinct roots are there. If delta is equal to 0, it's only one root. Plus or minus disappear if delta is equal. If delta is negative, we get a negative number inside the square root. So we get two complex roots. So what I have to explain next time is the complex roots case. Again, I will tell you how to write down the solution. But I will do a little bit of theory just to explain, like I did for equal roots case, say how to write down the solution. So that will complete the discussion on second order homogeneous linear differential equations with constant coefficients. After that, we shall do non-homogeneous ones and finish the section on differential equations. So let us see how many students participated today. I'm really disappointed, you know, if you are not participating, pointless me doing this. You understand? I need students to be there. True, we are putting it on the web, but online you can go through the note, but it's not the same. I want you to be there when the lecture is done. I mean, if it had been physical, you have to come now. So I know that there are no power cuts during this time anywhere in the island. So yes, tell the others also, because I will, to teach that need to be there. So students should be there. Otherwise, I can just record this and just do it alone and put it, upload it to the LMS. No point in doing it. Okay. Sir, antima gana hadapu kole pennana puluwan. Could you please explain the theory part? Antima gana hadapu kole. Antima gana. Tell the other students. Any message that Miss Sanuri has sent a message. I mean, some students are first year. Some students have told me can participate. Sir, lamai him online thina koda වැඩි එන්නේ නැහැ කියලා මැත්ස් එකට තමයි කියලාත් මේ ෆස්ට් ඉයර් එකේ 200 ගාණක් ඉන්නවා online එකට. So if you don't it's not ඉන්න ඕනේ 100 පන්නලා ඉන්න ඕනේ කොහොමද. So anyway, I don't have to say it. No, I have, if it is interesting enough, you will participate. So, how did they make an idea? කියන්න අනිත් ළමයින්ට ඒගොල්ලන් පාන්ද නැගිටලා මේ එන්න කියලා next Tuesday, not Tuesday, next Wednesday, we shall finish differential equations and start the last section on functions of several variables. ඒක ලස්සනයි graphs අඳින්න තියෙන surfaces අඳින්න තියෙන්නේ. Start with that. I think yeah. Okay, 9:05. So you have some of you have lectures, Neil. We shall stop there. Message. I need students to participate. If you are going to be registered for this course, you should be there for lectures. Okay? So we'll stop there.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
You're welcome. If you have any difficulties, just send me a WhatsApp message. I usually during a day about 10 WhatsApp checking difficulties of students are answered. So don't hesitate to ask me. Okay, you can even call me and ask. Same number as the WhatsApp number. Okay, bye.